your retriever returns the top 10 chunks from the vector database. But the truly relevant ones might be ranked 3rd, 6th, and 9th. Your language model only sees the top 3, so it never reads the best context. Reranking adds a second smarter scoring pass that reorders those 10 candidates before the language model ever sees them. It is one of the highest return improvements you can make to a RAG system. Two-stage retrieval divides the work between two models with different strengths. The retriever runs fast and fetches a large candidate pool of maybe 20 documents. It optimizes for recall. Get everything that might be relevant. The reranker then takes those 20 candidates and scores each one much more carefully against the query. It optimizes for precision. Surface only the genuinely best matches. The language model then reads only the top 4 after re-ranking, getting far better context. This is the key architectural difference. A bi-encoder, which is what we use in the vector database, embeds the query in each document separately and compares their vectors. It is fast because document vectors are pre-computed, but it is less precise because the query and document never interact directly. A cross-encoder takes the query and one document concatenated together and produces a single relevance score. It is slower because it must run separately for every candidate, but far more precise because it models the full interaction. We load the cross-encoder using the Sentence Transformers library. The model MS Marco Mini is a lightweight but very capable re-ranking model trained on the MS Marco passage ranking dataset. We call predict with a list containing the query and one document. The output is a raw relevance score. Higher means more relevant. Here, a score of 9.43 signals a strong match. The first part of the re-rank function builds a list of query and document pairs, one for each candidate chunk. We pass the entire list to predict in one batch call rather than calling it one document at a time. The cross-encoder processes all pairs in parallel on the GPU or CPU and returns a score for each. Batching is important here. Running predict in a loop for each document individually is much slower than batching everything together. The second part pairs each score with its document using zip, sorts them in descending order by score, and returns only the top n documents. If we retrieved 20 candidates in stage 1 and call re-rank with top n equal to 4, we get back the 4 documents the cross-encoder considers most relevant to the query. These 4 replace what the retriever would have passed to the language model directly. If you do not want to host your own cross-encoder model, Cohere offers a re-ranking API that is extremely easy to plug in. We create a Cohere re-rank object and pass it to LangChain's contextual compression retriever alongside our hybrid retriever from episode 6. The compression retriever automatically fetches candidates from the hybrid retriever and then passes them through the Cohere reranker. The result is a drop-in upgrade to the entire retrieval stage with 2 lines of code. Plugging re-ranking into the full pipeline follows the same pattern we have seen every episode. We replace the retriever in our chain with the re-ranking retriever. Everything else stays exactly the same. The prompt, the language model, the output parser. The chain now runs 3 stages automatically. Hybrid retrieval to get 20 candidates. Cohere re-ranking to surface the best 4. And the language model generating a grounded answer from those 4. Re-ranking adds latency, so you should add it deliberately, not by default. The right time to introduce it is when your answers are sometimes correct, but frequently miss a key detail that is actually present somewhere in the retrieved chunks. It also helps significantly when your document corpus has many chunks that sound similar on the surface. The extra 100 to 300 milliseconds of latency from a cross-encoder is almost always worth it when precision is the bottleneck. You now know how two-stage retrieval works, why cross-encoders are more precise than bi-encoders, how to build a re-ranker from scratch with sentence transformers, and how to drop in the Cohere re-ranker with 2 lines of LangChain code. In the next episode, we tackle query transformation, techniques like hide and multi-query that improve what you send to the retriever before it even starts searching. Subscribe so you do not miss it. See you in the next one.